retirees for the organisation. He's the former head of microbiology, Department of Physiology, Anatomy and Microbiology at La Trobe University. I'm sure that's just not designed to trip me up first thing on Monday morning. But with research interest in the study of neurodegenerative disease, mitochondrial biology, Parkinson's disease, and the role of mitochondria in disease, including around white blood cells and in ME CFS patients. I get bonus points for getting that all out in one go. His groundbreaking work is widely published and it recognises the complexity of this disease and the work we have to go ahead to be able to understand it further. So I thank you, Professor Fisher, for stepping up today.
Thanks, Peter. Yes, the complexity of the disease you've already heard about from some of the patients, and they can tell the story of what it's like living with it much better than I, so I'm not going to try to do that. My daughter actually has ME CFS as well, but she's at the mild end of the spectrum, so her story is nowhere near as compelling as the stories that we've heard today. ME CFS has been the elephant in the room for a long time, not only in the medical profession, but also in research. And as a consequence of that, the average funding for ME CFS research, biomedical research, over the last 3 decades has not been much more than about $150,000 per annum. This is for a disease that, economically speaking, is costing the country of the order of $15 billion per annum. Now that's a big difference. The number of patients that you're talking about in relation to ME CFS, as you've heard already, is 250 to 500,000. That's more than we have with Parkinson's disease, which I also work on, and yet the funding for research into it is an order of magnitude less than is available for Parkinson's disease. So ME CFS is a complicated, complex illness, but it is also a neglected illness, not only amongst the medical profession, but also in the research community, and that's because of the lack of funding. So with that small amount of funding, Australian researchers have been making key findings in the area of what is wrong with cells in ME CFS cells. And I just want to mention 3 of those things. Some of this work is from my lab, some of it from others. But basically, the compartments within cells called the mitochondria in blood cells, well, they're called mitochondria in all cells, but in blood cells, they are producing the energy currency of the cell, the ATP of the cell, the fuel of the cell, about 25% less efficiently than in normal, healthy control cells. Now that makes a big difference because the cell tries to adapt to that, and when it tries to adapt to that, it basically turns on all of its energy compensatory mechanisms to try to produce more. So in a normal state for that cell, it is already maxed out in terms of what it can possibly do. So an ME CFS patient can't ask more of it. It's already running at its maximum. So the cytopathology, the cellular damage in ME, or problems in ME CFS, involves inefficient energy production, and that is related to disturbed signalling inside the cell, signalling pathways that control mitochondrial energy production, and it involves disturbed compensatory energy metabolism. Australian researchers have made big contributions to this with this trickle of funding. I keep thinking how much more we could have done if we had been funded better over those 10 years. But even so, let me tell you some of the things that we have been finding most recently. We've been looking at biomarkers, for example. Now, many of you in the audience and ME CFS people are really well informed about science, will understand the general dogma of molecular biology. DNA has the information to make RNA, which conveys the information to the cell to make proteins. The proteins do the functions. And at each of those levels, you can find abnormalities in ME CFS cells. And to give you a feeling for that, 16% of more than 14,000 white blood cell RNA molecules we've measured, and 16% of them have abnormal levels in ME CFS cells. 17% of them in cultured cell lines that we've made from patients. 8% of over 3,000 proteins at abnormal levels in cultured cells from ME/CFS patients. 10% of about 300 different small molecules that we've measured in ME/CFS patient cells are at abnormal levels. 11% of the molecules that make up cell membranes are at abnormal levels in ME/CFS cells. That shows you the extent of the dysregulation in the cells from ME/CFS patients. You can take those thousands of differences and I wrote some software that allows us to search those thousands of differences and ask for a diagnostic subset. And with subsets of only 7 RNA molecules from ME/CFS white blood cells, 5 cultured cell line RNA molecules, or 8 proteins, or 7 fatty molecules from membranes, we can identify and distinguish ME/CFS cells from control cells with close to 100% accuracy. We can also identify the severity of the illness. We can correlate the severity of the illness with these changes, and we can correlate that with a subset of 4 white blood cell RNA molecules, or 5 cell line RNA molecules, or 8 cell line proteins. This has been done with a trickle of funds, but it had to be done, therefore, with small samples. We're talking, in the case of our work, 20 to 30 patients, 20 to 30 control cell lines, and that's not enough to know for sure that you've got the right molecules, that you've found the right ones for diagnostic tests. If we had more funding, we could have done it ages ago. But so I'm a bit frustrated, as you can tell.
You're getting old.
And I'm getting old. But we really think that research matters because diagnosis matters. You know that you have to have had ME/CFS for 6 months before you can get a diagnosis. If one of these things could be turned into a clinically useful test, you could get it straight away. And that would make a huge difference. It would also help validate your illness with the GP that you are speaking with. So they would understand this is real, this matters, and it is accurately diagnosed by a blood test. So that's where we're putting a lot of our efforts now. Thank you.